Hello Heiko, this is my answer for the bonus mark question 2. The question states, or asks us to, from a situation of a triangle with 2 masses on it and a pulley system at the top, to find the tension in the string as a function of the masses and the angles. To start off with, I just drew the diagram. Here you see the triangle, the 2 angles down here, the mass 1 coming down with gravity, the normal, the tension in the string pulling it up, and the force of it coming down given as mg sine A. I'm just going to call this angle A and this B. Then we see mass 2, normal, get what's getting pulled down, gravity, the force of it getting coming down this slope at mg sine B, and the tension in the string coming up to that little pulley at the top. The question also gives us information about the mass 2 and mass 1. So mass 2 is larger or weighs more than mass 1, and there is no friction in this situation. So to get the expression in terms of t as a function of mass and angle, you have to relate them somehow, and you can relate them with this equation right here that represents each one. And the forces, net force, with this, these will equal each other because the acceleration is the same on each one. So since the acceleration is the same, we can equate t minus mg1a, t minus m1 g sine a, over m1 equals mg sine b minus t over m2. I put the t minus mg sine a in that form because since we know that m2 weighs more, it's going to be more, there's going to be more force coming down compared to the m1, so I made m2 greater than t, just to keep the equation nice and neat. So if we do our simplification of the equation by doing the cross multiplication, and we get our m2, so we're doing on the right hand side, the m2 times this, the m1 times this, then minusing them from each other with the m1, m2. We can take the expansion of these from the multiplication of the denominator. That will all equal 0 because I took the right hand side of the equation, left hand side of the equation, put them on one side. That will equal 0. On this page, I took the t out of the m2 plus m1 and the m1, m2, g out of the sine A, sine B, and that will still be over m1, m2. You can see that in this bottom equation, how the t is in the m2 and also the t is in the m1. So then the m1, m2, mg is in the sine A and also the sine B. So as we simplify it some more, we can take this m1, m2, we can times the right hand side, so that times 0 will give you 0 obviously. And if you bring this m1, m2, g sine A plus sine B over to the right hand side, and then divide that by the m2 plus m1, will give you t equals m1, m2, g, open bracket, sine A plus sine B, close bracket, all over m2 plus m1. This is done because we want to, as the question states, get t as a function of the masses and the angles, as you can see there. And then the part B was to determine a condition for which the masses are at rest or in uniform motion. So this question wants us to get a condition for the inputs or the situation so that the masses can be at rest or in uniform motion, and the acceleration will be 0. So there won't be any accelerating, uniform motion, or if at rest, there won't be any movement. And this means it has to be somewhat of a static equilibrium. So then I kept it simple, as KISS tells me to do. And I put the forces the same, so the M1G sine A will equal the M2G sine B. And you can get a lot of information out of this simple equation, a lot simpler than the MA equals T minus MG sine A and the mass 2 version. So we're only working with the MG sine A and the MG sine B. And from these we can get M1, M2, the A angle and the B angle with only 3 different terms or information. And I wrote down here the condition of the masses will be the masses or the forces can be equal with the other side or the mass on the opposing side from the one that you're already you're trying to work out. So for example, if you're trying to work out the mass 1, you will have the M2, which is proportional to the angles at which the 2 slopes are at, or affected by the proportion of these slopes. So if we have a question that asks us to figure out either M1 or M2, I can come to these equations. I can say, because I know that the forces will be equal to each other, since there's no acceleration or they are at rest, I can put it into this equation, come up with a much simpler answer. That's the condition. So the M2 will be times by the proportionate of the sine B, so the second angle divided by the first angle. So let's explain it with this. So if we're trying to work out the mass 1 here, we know, or we can definitely figure out either one if the question allows us to. And then if we know these 2 angles, we can plug it into the equation on the back and we can get either one of these masses. So yeah, that proportionality in terms of the other mass is the condition that I arrived at. And obviously you can get the A and the B angle very easily from these equations as well, being the inverse sine function. M2 times sine B over M1 will give you A, so that mass 2 times the angle 2 over the first mass, if you put that in the inverse sine function, will give you A, and same with B with the mass 1 first angle and the mass 2. I hope this answered the condition, or at least gave you enough insight to how I understand the concept of this, to give me some of those credits. Yes, thank you very much, Heiko. Yeah.